Have you ever listened to a watch tick? That tiny rhythmic sound is more than just a background noise. It's the heartbeat of time itself, quietly marking each passing moment. That tiny, steady beat is time being measured second by second. Each tick is a promise that time is moving forward, never pausing, never skipping a beat. We check our watches constantly, catching buses, meeting friends, staying on schedule. Our lives are shaped by these small devices, guiding us through busy days and quiet moments alike. But how does this small device know exactly how long a second is? What secret lies inside that allows it to keep such perfect time? The answer isn't magic, it's science. A blend of human curiosity and technological innovation. Inside most modern watches is a hidden heart, not of muscle but of crystal. This crystal is the unsung hero of timekeeping. This crystal vibrates with astonishing precision, far faster than we can see or hear. Its movements are invisible to the naked eye, yet they control the very flow of time on your wrist. Its silent pulse is the secret behind your watch's accuracy. Every vibration is counted, ensuring that each second is measured with remarkable consistency. This is the story of how humans harnessed a natural material to solve the age-old problem of keeping time. It's a journey from ancient sundials to the marvels of modern engineering. Before quartz, timekeeping was complicated and expensive. Only a few could afford truly accurate watches, and even those needed constant adjustment. The quartz watch changed everything, making accurate timekeeping affordable and universal. Suddenly, precision was available to everyone, everywhere. It was a quiet revolution that transformed our world. Our days became more organized, our lives more connected, all thanks to a tiny crystal. So, let's look inside this everyday object and discover its secrets. There's more to your watch than meets the eye. We'll explore why its crystal heart beats exactly 32,768 times per second, a number that holds the key to its precision, and why this frequency is so important for keeping perfect time. By the end, you'll see the ingenuity hidden in the simple things we use every day. Even the most ordinary objects can have extraordinary stories. It's a story of physics, engineering, and a rock that vibrates. Let's dive in and uncover the secret pulse of time together. For centuries, the art of timekeeping was built on intricate systems of gears, springs, and pendulums, mechanical marvels that were both beautiful and complex. These devices, crafted by skilled watchmakers, represented the pinnacle of precision engineering in their era, but they were also delicate and required constant attention. Even a small bump, a jolt, or a sudden change in temperature could disrupt their delicate balance, causing them to lose or gain time. Owners had to wind them regularly, and only expert hands could keep them running smoothly. Maintenance was a ritual, and repairs could be costly and time-consuming. But then, in the 20th century, a revolutionary idea took shape. What if electricity and a special crystal could be harnessed to keep time, replacing the old mechanical systems? This was the birth of the quartz watch, a leap forward as dramatic as trading a horse-drawn carriage for a high-speed sports car. The difference in performance and reliability was astonishing. Powered by a tiny battery, the quartz watch was not only tough and low maintenance, but also incredibly accurate, keeping time with a precision that mechanical watches could only dream of. Suddenly, precise timekeeping was no longer reserved for the wealthy or the elite. Quartz watches made accurate time accessible and affordable for everyone, from students to business professionals. Quartz watches truly democratized time, transforming it from a luxury into a practical, everyday tool that anyone could own and rely on. This shift changed how society functioned. With reliable, synchronized timepieces, global communication and scheduling became more efficient, connecting people and businesses across continents like never before. The world began to run on quartz time, with cities, companies, and entire industries depending on this newfound accuracy. The secret behind this revolution? A tiny tuning fork-shaped piece of quartz crystal hidden inside each watch. Unlike mechanical watches, which rely on slow, swinging parts, quartz watches use the super-fast, invisible vibration of this crystal, vibrating thousands of times per second. This high-frequency pulse is the foundation of their remarkable accuracy, providing a steady, unwavering beat that keeps perfect time. It's a completely new way of thinking about time, using the laws of physics and the natural properties of quartz to create a near-perfect rhythm, far beyond what gears and springs could achieve. The quartz watch wasn't just an improvement, it was a revolution that forever changed the world of timekeeping. And it all starts with that tiny, unassuming crystal, small enough to fit on a fingertip, yet powerful enough to change history. So, how does this remarkable technology actually work? Let's take a closer look inside the Quartz watch. Let's compare the old and the new, two worlds of watchmaking, each with its own story and appeal. Mechanical watches are powered by a tightly wound spring, which slowly unwinds, turning a series of intricate gears and a balance wheel that swings back and forth with mesmerizing precision. Each swing of the balance wheel moves the hands forward, a delicate centuries-old dance of metal parts working in perfect harmony. But these moving parts are sensitive to gravity, temperature, and even the way you wear the watch, making them less accurate than you might expect. Even a well-made mechanical watch might gain or lose a few seconds each day, requiring regular adjustment to keep perfect time. Quartz watches, in contrast, have far fewer moving parts, making them simpler and more robust. A small battery sends electricity to a quartz crystal, causing it to vibrate at a precise frequency, 32,768 times per second. A microchip counts these vibrations and sends a perfectly timed pulse to a tiny stepper motor, which moves the hands with remarkable accuracy. The result? Quartz watches are far more accurate, often off by just a few seconds per month, a huge leap over mechanical timekeeping. They're also cheaper to make and easier to maintain. Just change the battery every few years with no need for complex servicing. Mechanical watches, on the other hand, require expert care, regular servicing, and a skilled hand to keep them running smoothly. Quartz watches can be mass-produced with incredible consistency, making accurate timekeeping accessible to everyone, everywhere. It's a bit like comparing a classic car, full of character and tradition, to a modern electric vehicle, built for efficiency and reliability. Both are impressive feats of engineering, but Quartz is the reliable workhorse that powers our daily routines, from the office to the outdoors. The leap in accuracy and affordability brought by Quartz technology truly changed everything, making precise timekeeping a part of everyday life. That's why Quartz watches became the new standard for most people. Now let's take a closer look inside and see what makes them tick. Open up a Quartz watch and you'll find a surprisingly simple layout. First, the battery, a small silver cell that powers the whole system for years. Next, the quartz crystal, hidden inside a tiny metal can, shaped like a tuning fork. When electricity flows through it, the crystal vibrates at a precise frequency. The integrated circuit, or microchip, counts these vibrations. Once it reaches the magic number, it sends a single electrical pulse. This pulse goes to a stepper motor, which turns a tiny gear exactly one step. The gear train moves the hands on the watch face. Each tick you see is the stepper motor completing its 1-second rotation. No maze of gears, just a battery, a crystal, a chip, a motor, and a few gears. It's a marvel of simplicity and efficiency. Every part has a clear job, working together to keep perfect time. That's the beauty of quartz engineering. Now let's focus on the star, the quartz crystal. Quartz is a common mineral, silicon and oxygen atoms in a repeating crystal structure. Its secret power? The piezoelectric effect. Squeeze quartz and it generates electricity. Apply electricity and it vibrates. This vibration is incredibly stable and precise. Scientists cut quartz into a tiny tuning fork shape for watches. This shape vibrates at a specific frequency, 32,768 times per second. The high frequency means more ticks to count, making timekeeping more precise. While a mechanical watch's balance wheel swings a few times per second, quartz vibrates thousands of times faster. The result? Unmatched accuracy. The crystal's stability means it's barely affected by temperature or movement. That's why quartz is the perfect heart for a watch. It's a tiny, reliable engine for measuring time. But how does this effect actually work? The piezoelectric effect is the key. When you squeeze quartz, it creates a tiny voltage. Apply voltage and the crystal bends or vibrates. In a watch, the circuit sends an alternating current, making the crystal vibrate back and forth. This vibration generates its own electrical signal, creating a feedback loop. The circuit listens to the crystal's signal and times the next pulse perfectly. This keeps the crystal vibrating at its most stable frequency. It's like pushing a swing at just the right moment to keep it going. This feedback loop is the engine of quartz accuracy. It turns electrical energy into a precise mechanical rhythm. That's the magic inside your watch. Why does the crystal vibrate 32,768 times per second? It's not random, it's perfect for digital circuits. 32,768 is 2 to the 15th power, a number computers love. The microchip divides the crystal's frequency by 15 times using simple electronic switches. Each divider halves the frequency step by step. After 15 divisions, you get exactly 1 pulse per second. This makes the electronics simple, small, and energy efficient. It's a brilliant use of binary math and crystal physics. The result? A perfect, steady heartbeat for your watch. That's why 32,768 is the magic number. It's elegant engineering in action. Now let's see how that pulse moves the hands. The microchip's job is done. It's created a single pulse every second. But how does that become the movement of the hands? Enter the stepper motor. Unlike regular motors, a stepper motor moves in tiny, precise steps. Each pulse energizes an electromagnet, turning a wheel just enough to move the second hand 1 tick. Gears transfer this motion to the minute and hour hands. The stepper motor is efficient and durable, needing little power. Each tick you see is the result of 32,768 vibrations, counted and divided down to 1 perfect second. This system is simple, reliable, and long-lasting. It's the final link between crystal precision and the time you read. That's the journey from vibration to visible time. The Quartz watch is a masterpiece of simplicity and precision. A battery powers a crystal, a chip counts vibrations, and a motor moves the hands. This technology didn't just change watches, it changed the world. The same principle powers computers, phones, cars, and more. Quartz watches made precise timekeeping universal, paving the way for the digital age. Understanding your watch reveals the ingenuity in everyday objects. It's a reminder that even simple things are built on brilliant ideas. So next time you check the time, remember the invisible dance inside. That tiny crystal is a testament to human creativity. Every tick is a triumph of science and engineering. Stay curious. There's wonder in the world all around you. Ask, how does that work? The answers are often amazing, and that's the real magic of time.